Hi, linear algebra students. This is the first theorem in the section 2.2 that I put on YouTube basically because I want to focus your attention elsewhere, okay? And it's important to know why the inverse of a matrix is unique, but it's not the type of proof that I would actually ask out of you now that I see a typo right here. Okay, so that's the theorem. The inverse of a matrix A, if it exists, is unique. So, which basically means that a matrix doesn't have two inverses. So, how do we build up a proof for that? The idea is we suppose that there are two matrices, B and C, that both satisfy this. Okay, so they both satisfy the condition for it to be an inverse. So A times B equals BA is equal to I, but also A times C is equal to CA is equal to I. And we want to prove that it forces B to be equal to C. So how are we going to achieve that? Quite simple. So yeah, let's go like one argument after the other. So I'll label this argument number one. So since B, so we take basically, we take AB is equal to I, and we multiply both sides of this equation by C. And we're going to multiply it, let's say, on the left. And left multiply both sides by C. Okay? So if these two matrices are equal, it means certainly that C times AB is equal to C times I. So this is the first argument. Then the next argument is to use the associativity of matrix multiplication. So in other words, we can actually go like this instead. And C times I is equal to C, okay? We saw that in the properties of the last section, but here we go. So we can actually write this by associativity. So by associativity of matrix multiplication. And now C times A is equal to I. So in other words, we are using this now, okay? So we replace this matrix with I times B is equal to C, and I times B equals C. So that concludes the proof. Okay. So what I mean by this concludes the proof is that we prove that if there's two matrices that satisfy this property, they are forced to be equal. In other words, the inverse of a matrix A is unique. So there's just one matrix that satisfy these two property, this property for a given matrix A, of course. I hope that helped. See you either in class or in the next video.